All right, so chapter 4 starts off with a slightly new concept. It's the concept of an absolute maximum and an absolute minimum. Each of the problems in section 4.1 either gives us just a segment of a graph or gives us an equation and describes the segment of a graph that we want to look at. And it asks us to find the absolute maximum and the absolute minimum over that small portion of a graph. The absolute maximum is the y-coordinate of the highest point on the graph over that given region. The absolute minimum is the y-coordinate of the lowest point of the graph in that given region. And any points that aren't the very highest point nor the very lowest point aren't an absolute maximum or an absolute minimum. So specifically, when I look at problem 2, if I wanted to find the absolute maximum and absolute minimum, the y-coordinate of the very highest point is the absolute maximum, which is y equal to 5. The y-coordinate of the very lowest point, which is 1, is called the absolute minimum, and this point's y-coordinate isn't anything. Generally, when we describe an absolute maximum or an absolute minimum, we include the x value. So in number 2, I might say the absolute maximum, and I like writing y equals, is y equal 5, and it occurs when x equal to 1. Every now and then I'll get lazy and say the 0.15 is the absolute maximum, meaning the largest y value of this function in this window is 5, and it occurs at x equal to 1. Similarly, for this minimum point, if I wanted to describe this nicely, I might say the absolute minimum for which means the smallest y value of any point, that doesn't even look right, means the smallest y value of any point in this region is y equal 1, and it occurs when x equal to 3. I know that as I get deeper into this section, I'm not going to want to write this for every single problem, so I'm going to develop some sort of shorthand that means the same thing to me. But this is the proper way. If you're given a graph and you're asked to find the absolute maximum and absolute minimum, the absolute maximum is the y-coordinate of the highest y value that you see of any of the points in that graph. The absolute minimum is the y value of the lowest point. So when you go to do number 1, you're going to have an absolute maximum of y equal to 7, which occurs at x equal to 4, and an absolute minimum of y equal to 3, which occurs at x equal to 2. So the first 9 problems, they all just give us graphs, and we're asked to look at the graph and describe what the absolute maximum and absolute minimum is. When I look at problems 3 and 4, they're similar problems. They're given a graph, but not, just like a fragment of the graph. And within that fragment, the point that's highest, its y-coordinate is the absolute maximum. So for this problem, I might say, and there's the absolute maximum is y equal to 5, and then I'm going to say when x equal to 2. So this is maybe the abbreviation that I'll use rather than writing out a whole sentence. That's probably more appropriate. The absolute maximum is y equal 5. It occurs when x equals to 1. This is probably means the same thing to me. So the absolute maximum, the highest y value of any point on this graph is y equal to 5. It occurs when x equals to 2. The absolute minimum is going to be the y value of that point. So I'm going to say the absolute minimum is y equal to negative 4, and it occurs when x equal to 5. Any point that isn't the highest or lowest point in the graph, like this point 0, 1, that y value isn't bigger than any of the other y values, nor is it the smallest y value, so it doesn't go in my answer. So you should give number 3 a crack. I'm going to bring 5 up in a second. I'm going to do 6 first, and then I'll let you do 5. So when I look at 6, it has 2 absolute maximums, because this point right here was 2 points that have the same maximum y value. So I'm going to write this, my absolute maximum, the largest y value of any point, is y equal to 10, and it occurs twice. It occurs when x equals 2 and -2. The smallest y value of any of the points in this interval is -6. And so I'm going to say the absolute minimum is y equals -6. And I'm going to say when, rather than saying occurs when, x equal to 0. So you could have multiple points that are maximums and multiple points that are minimums. On your number 5, you're going to have multiple points that are minimums and only one point that's a maximum. So when you go to answer your number 5, you should say the maximum y value is 6, it occurs when, and then the minimum y value is -2, and it occurs when. I'll flash your number 7 up here, thinking that you can do it before I do number 8, but if you can't, just rewind the video, and after I do number 8, you'll probably be able to do number 7. I'm not sure that's the case, though. So for this problem, I'll just do it. You have an absolute maximum of y equal to 12, and it happens when x equal to 5, and you have an absolute minimum of y equal to -8, and it occurs when x equals 0 and x equal to 3. So again, the absolute minimum is the y coordinate of the smallest y coordinate of any points on the region of the graph that you're given. The absolute maximum is the y coordinate of the highest point, that are the biggest y coordinate of the points that you're given. And then you always include what values of x made that happen. All right, so for my number 8, the highest point is at 0.28. So I have an absolute maximum of y equal to 8. I'm going to say comma when x equal to 2. And that point's the lowest point. Its y coordinate is -1. So I'm going to say we have an absolute minimum of y equal to -1 when x equal to -1. So you should be able to do something similar for number 9, and that will be the end of the really easy problems, and then we'll get on to the kind of easy problems. All right, so the rest of the problems between 10 and 29, which means how many do we have? 10 and 20, 10 problems each to do, I guess, ish, give us an equation and the value of x's that we want to look at that equation, the window that I want to look at for that equation under. Let me graph to show you what I mean for number 10. For number 10, in y1, I'm going to graph the function x squared minus 2x plus 5. And when I go to set my window, I'm going to do x min is -3, x max is +3, and I don't really know where to set the y's right now because I don't know the y coordinates of any of the points. But I'm going to leave those at 10. And what I'm going to get is a graph that's going to look a lot like the graphs that I gave you. And we're going to use that graph. We're not going to use the graph. We're going to use calculus, but I could use that graph. So I'm going to go y equals now, enter the function. So clear x squared minus 2x plus 5, window, x min is -3, x max is 3, y min is -10, y max is 10. 10. And this would be the equivalent of the graph that you'd be given. I don't think my y's are high enough. And again, we don't need to use graphs to do this, but I want to try to make a connection. So I'm going to change my y's to go way higher, maybe like to the 30s. And that's going to do me better. So this graph is going to have an absolute maximum at whatever that y value is, and that's at x equal to -3. The far right point is when x equals positive 3, and that's probably a nothing point. And somewheres in here, I don't know what x value that is, but my guess is that's at x equal to 1. It has a minimum y value, whatever the y coordinate of that point is, and that happens at x equal to 1. So I would guess my answer is the absolute maximum is going to be the y coordinate of that point. It occurs at x equal to 3. The absolute minimum is going to be the y coordinate of that point, and it looks like it occurs at x equal to 1. Let me show you how to do this now with calculus, because we don't need to use our calculators, but heck, I'm going to wind up using my calculator to get y values anyways because it's easier. So it's nice having the function in there. The graph looks something like this. I suspect this is the point negative 3 comma something. My guess is that's the point 1 comma something. And this is the point 3 comma something. And it doesn't really even need to be mentioned because it's not the point that's going to give me the absolute maximum or absolute minimum. To do without a graph to get the maximum or minimum, the first thing you're going to do is find the derivative of the given function. So my given function is f of x equals x squared minus 2x plus 5. I'm going to take its derivative. The derivative of x squared is 2x. The derivative of minus 2x is minus 2. Once I find my derivative, I'm going to get a critical number by taking the derivative and setting it equal to 0. And now I'm going to make a table. And always on my table, I'm going to start off with the x values that are given, and I'm going to call that my x column. So my x column is always going to have the x coordinates of the points, the endpoints that are given, in this case the negative 3 and 3. And in addition, any critical number that's between those two values of x will go in this table. If this x value was like 5 and it wasn't between negative 3 and 3, I wouldn't include it in my table. But it's between negative 3 and 3, so I'll include it. Now for each x value, I need to get a y value. And generally, you find y values by hand. To do this y value, I'd have to go f of negative 3 and go to the original function and go equals negative 3 squared minus 2 times negative 3 plus 5. That's 9 plus 6 plus 5. That's 20. So we can, if we want, take the values in my x column, plug them into the original function to get my y values. And so that gives me that this was the point negative 320. I don't have to. If the y values come out to be something that's not a nasty decimal, then I can use my calculator and the value function on my calculator to get the y values. So I have this function in here. I'm going to go second calc value, and if I typed negative 3 in, you'd get that point negative 320 that I just did by hand. The other two y values I'm going to get using the value feature rather than the by hand feature. So second calc value, type in 3, and I get 3/8, which is this far point out here. And the last one I'm going to do second calc value, type in 1, and I get 4, which is that point. So this graph and this table tell me the same things. So now I look at my table. The absolute maximum is 20 because it's the biggest y value. It occurs when x equal to negative 3. The smallest y value is 4. It occurs when x equal to 1. So my answer to this, I'll try to squeeze it in here. The absolute max is y equal to 20 when x equal to negative 3. And that's kind of splitting that point up. And the absolute min is y equal to 4 when x equal to 1. So for each of the problems between 10 and 29, I don't have to ever sketch a graph, but I'm probably going to sketch a graph for all of them, specifically because I can generally use my value feature to get the y's, and I can kind of make sure my answer is right. So you should be able to make a crack at number 11. So the video might have a bit of a hiccup. I didn't like my attempt at problem 12, so I'm redoing it. So let me get started. I'm going to graph the function f of x equals x cubed minus 6x squared, and I'm going to set my window to cover the x's that are given to me. So my x min is going to be negative 2, my x max is going to be positive 2, and I'm not really sure what the y's should be. I'm going to graph it with standard y's, and if I can see if the entire graph fits on my screen, then I won't have to play with the y's. If my entire graph doesn't fit on my screen, then I'm going to have to play with the y's, and we'll get to that in a bit here. So let me graph the function y equals, already have it in there, x up arrow 3 minus 6x squared. Set my window. The x's have to be negative 2 and 2 because this is the window I'm told to work with. For the y's, if I wouldn't naturally know the y's, negative 10 to 10 seems like a fine window. When I hit graph, the graph goes off the screen around x equal negative 1 and a little bit past x equal to 1. My y's need to be expanded a little bit, and what I'm going to do is find the y values that correspond to x equal negative 2 and x equal to positive 2, and this will give me a better idea of what my y min and my y max should be, at least what my y min should be. So I'm going to go second calc value, type in negative 2 for y, and this tells me the graph goes somewheres at x equal to negative 2. The y coordinate of its point is negative 32. That tells me my y min has to be at least at negative 32. Let me do the same for x equal to 2. Second calc value, type in 2, and I get negative 16 when x equal to 2. And I'm making a really crude graph. When I look at the y's that I get for the x's at the edges, they're both negative. That tells me my y min is probably not so good. But my y max, it looked like I was seeing the top of the graph. I'm going to leave my y max at 10, and I'm going to change my y min to something that accommodates negative 32. Say negative 40, negative 50, negative 60. Negative 40 seems adequate. Now when I graph it with this window, I'm going to see a better version of the graph. So it goes, looks like it goes through the origin. My graph isn't stellar, but it's definitely good enough to answer the questions I believe. It looks to me like this point, negative 2, negative 32, is the point where the absolute minimum occurs. And if I had to guess, probably the point 0, 0 is the point where the absolute maximum occurs. My guess at an answer that I have to back up with some calculus, my best guess at an answer is that there's an absolute minimum of y equal to negative 32, which occurs when x equal to negative 2. And this wording is a little more wordy than I have been doing, so you don't have to get quite this wordy. The abbreviations of what I've been writing would be fine. And for my absolute maximum, I would guess there's an absolute maximum of y equal to 0, which occurs when x equal to 0. That's my guess. If this was a test question, you wouldn't get any points for a correct answer if you didn't show a little bit of work. So even though I probably know a correct answer ahead of time, let me do the work that's necessary for problem 12. So the work that's required to get full credit on the test is to take the derivative, find any critical numbers between the given values of x, negative 2 and 2, make a table, find y values, and use that table to answer my question. So the derivative in problem 12, the derivative of x cubed is 3x squared. I bring the 3 out front and I lower the exponent by 1. The derivative of minus 6x squared, I multiply the exponent 2 by 6 and get a minus 12x to the first power. So I'm going to get my critical number by taking that derivative and setting it equal to 0. Because there's an exponent and it's set equal to 0, I'm probably going to solve by factoring. And this is a 1 parentheses factoring because there's a common factor I need to factor out. The common factor is 3x. When you factor out a 3x, you're left with an x minus 4. Then I'm going to take 3x and set it equal to 0, and x minus 4 and set it equal to 0. For the 3x, when you set it equal to 0, you divide both sides by 3, and you get a critical value of x equal to 0. And for the x minus 4, when you set it equal to 0, you add 4 to both sides and get x equal to 4. In terms of answering this question, x equals 4 is not between x equals negative 2 and positive 2. In another window, that x equal to 4 could be the x coordinate for a maximum or a minimum point, but we're going to ignore this for this problem because it's not in the given interval. So now I'm going to make a table of x values. I'm going to take the x values that are given in my interval, negative 2 and 2, and the critical number that's between those, 0, and find y's for each x. I've already found all these y's, but I'll find them again, and the easiest way to find y's is to use the value feature of my calculator. So to find the y for x equal negative 2, I'll go second calc, hit enter on value, type negative 2, and it gives me negative 32. If I'm doing a string of y values in a row, I don't have to do second calc and value again. I could just type the number 2, and it's going to show up next to a big X and hit enter, and it will plug it in and give me that negative 16. And again, I don't have to go second calc value to get the y value for 0. I've just gotten 2 y values. I can get the next y value just by typing 0 and hitting enter. Now that I have my table, I look at the y values, and the y value that's the smallest corresponds to the absolute minimum. So that point, negative 2, negative 32, because that's the smallest y value in my table, I break it up to say the answer for the absolute minimum. And then the point 0, 0, because it has the smallest y value, I break it up and make it my absolute, absolute maximum. Yes. 0 seems like such a small maximum, I wanted to say it was a minimum, but 0 is, that point 0, 0 is the highest point in this window, so it's certainly where the absolute maximum is. Alright, so I'm going to cut and paste this back in. Give problem 13 a try. There's going to be probably a hiccup between problem 12 and problem 14. Alright, so I'm going to give 14 a go here. Our 14 and your 15 should be a lot alike. Yours looks slightly more complicated because of this plus 2, but it's not going to be any more complicated. When you get into problem 15, it won't solve that differently than my problem 14. So for my problem 14, I like to know what I think the answer is going to be ahead of time. So I'm going to go ahead and sketch a graph, and I'm going to find the y-coordinate that corresponds to x equal negative 1. I'm going to find the y-coordinate that corresponds to x equal to 3, and I'm going to try to get a window that looks suitable for my answer. So I turn my calculator on, y equals, clear the function that's in there, enter now x up arrow 3 minus 3x squared, set my window. I know for certain I have to match up with the requirements of this problem. My x min and my x max have to be negative 1 and positive 3. I'm not sure what my y min and my y max absolutely have to be. What I'll do is I'll graph the function with whatever window I have in here already, or maybe I'll graph the function and start with the y's at the 10s, and if my graph goes off the screen, I'm going to find y values that correspond to x equal to negative 1, y values that correspond to x equal to 3 to get an idea of how I can improve my y values. So I have the function in. I don't have my x's set up for this problem. My x's need to go between negative 1 and 3. And I have my y's back down to the 10s. I hit graphs, and there's the point negative 1 comma something. That looks like the point 0, 0. That point, I don't necessarily know what it is, but off the edge here at x equal to 3, I'm not sure if the graph goes high enough or not. Let me, for just safety purposes, find the y value that corresponds to x equal -1 and find the y value that corresponds to x equal to 3. It could be that this graph is just perfect. So let me go second calc value, type in x equal -1. The reason -1 is because it's a value that's given to me. And it tells me the graph goes through the point -1, -4. I'm very crudely plotting the point -1, -4. Now I'm going to find the y value that corresponds to 3. Because I'm doing multiple y values, and I've just done one y value, instead of going second and calc and value again, I can just type the x value of 3, and it will give me the y value of 0. I guess this graph is just fine. So there's a couple points that I know for certain that the graph goes through, and it doesn't really look like the graph goes off the window ever. So the graph looks to do something like this. It goes from the point -1, -4. It looks like it goes through the origin, and that it dips back down and goes back up and gets to the point 3, 0. If I had to guess, to me it looks like, based on this graph more so than my graph, that these 2 points right here are both absolute minimum points. So there's going to be 2 absolute minimum points, would be my guess. And it looks like the point 0, 0 and the point 3, 0 are my absolute maximum points. And there's going to be 2 absolute maximum points, near as I can tell. Let me just go ahead and do the calculus work to try to figure out for certain if I have an absolute, 2 absolute maximum and 2 absolute minimum points by hand. I could actually maybe find this point on my calculator, but let me just do it all by hand. So now I'm stuck trying to get a better answer than I've come up with from my graph, because with my graph, because of these points that I wasn't 100% sure on, I'm not as confident about writing an answer down before I do my work. My work should match up with what I think my answer is going to be, and my work is going to give me this point as well. So I'm going to take my function in problem 14 and find its derivative. So f prime of x, the derivative of x cubed is 3x squared. The derivative of minus 3x squared is minus 6x. I'm going to find critical numbers by taking the derivative and setting it equal to 0. And I'm only looking for any critical numbers that are between -1 and 3. When I set 3x squared minus 6x equal to 0, I'll factor out a common factor of 3x. That will leave me with an x minus 2. Then I'll go 3x equal to 0 and x minus 2 equal to 0. For the 3x equal to 0, I'll divide both sides by 3 and get a critical value of x equal to 0. For the x minus 2 equal to 0, I'll add 2 to both sides and get a critical value of x equal to 2. Because 0 and 0 and positive 2 are between -1 and 3, they both are potential absolute maximums and absolute minimums. So this point right here, it probably really is the point 0, 0, corresponds to that x equal to 0. This point right here, or that point right there, my best guess is it has an x coordinate of 2. I need to find its y coordinate. So to be able to answer the question for problem 14, I'm going to make a table, and I need to have the x values of any critical values and any endpoints on that table. And it doesn't really matter the order. I could take the 2 x values that were given to me and write them first, and the 2 critical values that are between the x values that were given to me and write them second. I don't have to make this I don't have to take the time to write it from smallest to biggest or biggest to smallest. Now for each x I need to get a y. I have most of my y's already. I'm going to re-get those y's just in case I messed up by going second calc, hitting enter on value. I'll type -1 and hit enter. Tells me the y value that corresponds to -1 is -4. Then I'll type in 3 and hit enter. and the y value that corresponds to x equal to 3 is 0. Then I'll type in 0 and hit enter. The y value that corresponds to x equals 0 is 0, and then 2 and enter, and the y value that corresponds to x equal negative 2 is negative 4. So just like I suspected, there's going to be 2 absolute minimum points and 2 absolute maximum points. So when I go to write my answer, the 2 points that have y equal to negative 4 are going to be my absolute minimums because that's the smallest y value. And for those 2 points, I'm going to condense it into one sentence in my answer. So I'm going to say there's an absolute minimum, max minimum for those, of y equal to negative 4. Don't have much room here, so I'm going to be short. And I'll say when x equals negative 1 and positive 2. And so that took care of those 2 points. And the other 2 points are the high points, the point 0, 0 and the point 3, 0. Have small x values, but still the small y values, but still the largest y value. And I'm going to say there's an absolute maximum of y equal to 0 when x equal to 3 and 0. And that totally corresponds with this graph. I suspected I had 2 absolute minimum points and 2 absolute maximum points. I needed the calculus to get the x values of the points that were between the endpoints that were given to me. Alright, so once you give 15 a try, I'm pretty sure your window for 15 is going to have to be tweaked a little because this plus 2 kind of messes things up a little bit, and the fact that your x max goes out to 5, your y's are going to have to be a lot bigger than my negative 10 to 10s. Alright, 16 and 17, still in polynomials, which are nicer. So for 16, I graph this function between negative 2 and 2. So I go y equals clear x up arrow 4 minus x up arrow 3 plus 5 window x min negative 2 x max 2. I don't know if those y's at 30s are good, but I'm going to leave them there. And when I sketch a graph, that's probably a decent enough window. It looks to me like that y value is the absolute maximum y value. Somewhere in here there's an absolute minimum y value, and that's a nothing point. In order to see in 16 what's going on here, I have to really crunch the window. I'd probably, if I crunch the window to be my y's like between negative 2 and 2, I'll see better what's going on in the middle of this graph. Or I won't. Maybe make the y, I forget what this should be. I think maybe the y's are supposed to be between negative 5 and, hold it, between 4 and, I forget. I did this problem earlier. I think that might be the window that helps me see what's going on a little bit. So what's happening there, where it looked flat, it goes down, gets flat, and that point's going to be the absolute minimum. Let me go back to that window that I had on the 50s or the 30s. So this window, it made the absolute max easy to see. It doesn't make the absolute min easy to see because there's a little wiggle that I don't see here in the graph. But it's okay. The calculus will make this come out just nice. So algebraically, the first thing I'm going to do for 16 is find the derivative. So f prime of x equals 4x cubed minus 3x squared plus 0. Fine. Set it equal to 0. So 4x cubed minus 3x squared equal to 0. Factor out an x squared. So x squared times 4x minus 3 equal to 0. Set each factor equal to 0. X squared equal to 0. 4x minus 3 equal to 0. The only number squared that 0 is 0, so that has a solution of 0. For this one, I add 3 to both sides and get 4x equal to 3. Divide 4 by both sides and get 3/4. 0 is between negative 2 and 2, and 3/4 is between negative 2 and 2. So when I do my table, I'm going to put the negative 2 and 2 and both 0 and 3/4 because those are both between negative 2 and 2. I'm going to get all the y's I can using my value. This y right here, my calculator is going to give me a decimal, and that's not going to be suitable for a final answer, but it's going to be suitable for to help me determine the final answer. So now I'm going to go second calc value -2, and I get positive 29. Second calc value +2, and I get positive 13. Second calc value 0, and I get 5. And then second calc value 3 divided by 4, and I get 4.89. This 4.89 tells me that's the smallest y value, but that's not a suitable answer for a test. So to get the y value that I need here, I'm going to have to go 3/4 to the 4th power minus 3/4 cubed plus 5. I'm going to do that from the main screen of my calculator, because then I can go math enter to turn that into a fraction. So let me do this now. So second quit, parentheses, 3 divided by 4, up arrow 4, minus parentheses 3 divided by 4, up arrow 3, plus 5. Gives me that's that same 4.89. Now math, enter, and 1253 over 256 is what I want to write here. So 1253 over 256. So in terms of my points, the biggest y value is 29. The smallest y value is 4.89. The 5 and the 13 aren't the biggest nor the smallest y value, so they don't get included in my answer. So for my answer, I have an absolute max of 29 when x equals -2, and an absolute min of 1253 over 256 when x equals to 3/4. And never do I want a decimal answer for a y coordinate on our tests. You'll lose points if you do that, unless something really odd happens, and I'll write in the instructions. Well, it's okay to get a y as a decimal, but in general, I don't want any decimals as my y coordinates. I probably should have put those on the top of my table. All right, so give 17 a crack, and I'll move on to 18. And I'm going to stop graphing these for, well, maybe I won't, because I'm going to have to graph them eventually. So I'm going to do 18. You can do 19 maybe simultaneously. So for 18, I'm going to find the derivative. I have to use the chain rule because of the parentheses with an exponent. I'm going to bring this 4 out in front, leave myself some room, and write the parentheses with the exponent lowered by 1. Inside the parentheses where I left my room, I take the derivative of the original parentheses. The derivative of x squared is 2x. The derivative of -9 is 0. So my f prime of x, if I simplify this a little bit, is going to be 8x times x squared minus 9 cubed. Supposed to set this equal to 0, so I'm going to go 8x times x squared minus 9 cubed equal to 0. It's already factored, so now I'm just going to go 8x equal to 0, x squared minus 9 cubed equal to 0. For the 8x equal to 0, you divide both sides by 8 and get x equal to 0. When you have a parentheses with an exponent set equal to 0, it's just enough to set the inside of the parentheses equal to 0. And for this one, I'm going to factor it. That factors into x plus 3 and x minus 3. And then I'll set the x plus 3 equal to 0, the x minus 3 equal to 0, and get x equal to -3, x equal to +3. Now I'm going to make a table, and the values I'm going to put in are 0 and 2, and any critical number that's between 0 and 2. The 0 is already there, so I don't need to re-put this there. But the 3's, 3 is bigger than 2, it doesn't belong in the table. -3 is less than -2, it doesn't belong in my table. So my table is only going to have 0 and 2 in it. It has 0 for 2 reasons. 1, because it comes from a derivative. 1, it's a given endpoint. It has 2 because it was a given endpoint. -3 and 3 don't belong in my table. So now let me go to the graphing mode so I can get the y values without having to do any extra work. So turn my calculator on, clear, parentheses, x squared minus 9 parentheses, up arrow 4. And then my window has to go from 0 to 2. And the y's on this are likely huge because of the fourth power. I don't know how huge. I'm just going to graph this function. I don't see a darn thing, but I still can get my y values, even though I can't see the graph, by going second calc value, typing in 0. That's why I didn't see anything. There's a y of 65, 61. And then second calc 2, and I get a y of 625. So if I wanted to see this graph, my y's have to go bigger than 65, 61. So if I wanted to see this graph, this y max maybe have to bump up to like 7,000. So I have the 0 and 2, the endpoints in, and now I have y's that you'll see something. And so you have an absolute max there of 65, 61. It occurs at x equal to 0. You have an absolute minimum of 625. It occurs at x equal to 2. And nothing between is a high or a low point. The highs and the low points would occur at 3 and negative 3, but those aren't in this window, so I'm not worried about them. So I'm ready to write my answer. So I have an absolute max of y equal to 65, 61 when x equal to 0, and an absolute min of y equal to 625 when x equal to 2. So it's really nice to have the calculator because it's doing a lot of the grunge for me. So you should be able to give 19 a crack. It's basically the same kind of problem. You get the same obnoxiously large numbers. This is another time where I'm going to do an odd problem, just because graphing cube roots is a little bit easier than graphing fifth roots. So let me work through 21. I'm going to work through the algebra, then do the graphing and tie them together. And again, I'm going to do your problem 21. So I'm going to rewrite this problem with a fraction exponent. Fifth roots turn into 1/5 powers. Square roots turn into 1/2 powers. Cube roots turn into 1/3 powers. That's not the derivative. That's just writing it so I could use the power rule to take my derivative. So f prime of x is going to be 1/5 times x to the 1/5. And I need to subtract 1. And I'm going to subtract 5/5. So now I'm going to get f prime of x equals 1/5 x to the negative 4/5. I need to make that exponent positive, so I'm going to get f prime of x equals 1 over 5x to the 4/5. And I might as well write that as a radical. That's going to be 1 over 5 times the 5th root of x to the 4th. So when you have a denominator of a fraction exponent of a 5, you get a 5th root. To get critical numbers for a fraction, you have to separately set the numerator and the denominator equal to 0. So I'm going to go 1 equal to 0, and 5 times the 5th root of x to the 4th equal to 0. The 1 equal to 0 doesn't give a solution because there's not an x. For this one, I'm going to divide both sides by 5. That will give me the 5th root of x to the 4th equals to 0. And then I'm going to raise both sides to the 5th power. And when I raise both sides to the 5th power, on the left side, the 5th root's going to cancel. It's going to leave me with the x to the 4th. And on the right side, 0 to the 5th is 0. And when you're solving any x to a power equal to 0, the only value of x when you raise it to a power that's 0 is 0. So the only critical number I get for number 21 is 0. Fortunately, it's between negative 3 and 2, so it belongs in my table. So now in my table, I'm going to put the number negative 3 and 2, and I'm going to plug 0. I want to get the y values. And without my calculator, it's not hard to get y values. To get the y value when x is negative 3, you change that x to negative 3. You'd get the 5th root of negative 3. To find the y value when x equals 2, you change that x to 2. You get the 5th root of 2. And then to find the y value when x is 0, you change that x to 0. You get the 5th root of 0. The any power or any root of 0 is 0. Those are the correct y values, but they're not really that useful for me. Although this one must be the absolute minimum because it's the only one that's negative. and this one's positive, it's bigger than 0, it's probably the absolute maximum. Let me get decimal equivalents for all of these and sketch my graph just to make sure I'm not crazy here. So I'm going to put my y equals on, clear out the function that I just graphed in. To do a fifth root of x, I have to type the number 5, that means fifth root, hit my math key, and then after I hit my math key down to option 5, and then that means the fifth root. And then I'm going to put the x in a parentheses. So that's how I'm going to enter the fifth root of x. Again, I typed the number 5, I hit the math key, selected the option 5, and then I typed the x in. My window needs to go from x equal to -3 to x equal to 2, and I'm going to make my y's -10 to 10, and those might even be too big, but they definitely don't need to be in the thousands. So there's the minimum at x equal to, that the x coordinate is -3. There's the point 0, 0, which is not a maximum or minimum, and that point is the x equal to 2. Let me get the decimals for these just so we can know them. So second calc value, -3. When I plug in -3, I get -1.24. And then second calc value, +2. When I plug in +2, I get 1.14. And then second calc value 0, when I plug in 0, I get 0. It's easier for me to see the maximum and the minimum y values when I have them like this. So this point right there is where the maximum exists. That point right there is where the minimum, and that point's a nothing. So when I go to write my answer, I'm going to say there's an absolute max. I want the ugly y, not the decimal, of y equals the fifth root of 2. That's with that y value. And that's when x equal to 2. And there's an absolute min of y equals the fifth root of -3. And that's what I tried to write there. And that's when x equal to -3. Again, I'll probably never do problem 20. All right, so next group of problems have some e's. We're getting close to the end of this thing. All right, just a few more problems to go. Let me make a stab at 22. Let me just do the calculus and then match it up with my calculator. It kind of doesn't matter what you do first in terms of if you sketch a graph on your calculator to know what the answer is ahead of time and then do the calculus to confirm it, or do the calculus, get an answer, and then match it up with a graph. But I'm going to check my answers one way or another. I'm going to graph to check to make sure I'm okay. So for problem 22, if I'm dispensing for a second with the graphing, the first thing I want to do is take the derivative. There's a multiplication here, so I need to use the product rule. I'm going to do the derivative of x times the e to the x unchanged plus the derivative of the e to the x times the x unchanged using the product rule properly. So f prime of x is going to be the derivative of x is 1 times the e to the x unchanged plus the derivative of e to the x is e to the x times the x unchanged. I'm going to pull out my common factor of e to the x, and I'm going to get my f prime of x equals e to the x times 1 plus x. I'm going to get my critical numbers by taking f prime of x and setting it equal to 0. So I'm going to go e to the x times 1 plus x equal to 0. That will force me to go e to the x equal to 0 and 1 plus x equal to 0. E to the x can never be 0, so there's no solution here. And for 1 plus x equal to 0, you just minus 1 from both sides and get x equal to -1. So the algebra gives me a critical number of x equal to -1. I have to look at the given interval of x's and ask myself, is the critical number in the interval that's given to me? The interval that's given to me is x between 0 and 3. -1 is less than 0. It's not inside this interval. So I'm going to, even though it is a critical number, I'm going to ignore this critical number in terms of my final answer. So there's only 2 x values that need to go in my table because I'm given those and I don't pick up another critical number. Now for each x, I'm going to get a y. For x equal to 0, I'm going to go f of 0 to get its y. Go f of 0 equals 0 times e to the 0. E to the 0 is 1, so this is 0 times 1, and 0 times 1 is 0. I'll get this on my calculator too, but with e's, sometimes the y's come out on my calculator to be decimals, and I want to get a more accurate y. For the y coordinate that corresponds to 3, I'm going to do f of 3, plug in 3 for the x's, and I get 3e cubed, and that is a better answer than I'm going to get on my calculator. If on my calculator I entered, second quit, clear 3 second and ln for e cubed, my calculator gives me 60.26, and that's not so good, so I'm going to want that in my final answer. I think I actually have enough work for an answer even without a graph. I'm going to gamble. I'm going to write an answer down, and then I'm going to check on my calculator to make sure I haven't made some sort of mistake. So I'm going to say there's an absolute max of y equal to 3e cubed, and I'll say which occurs when x equal to 3, which means the right edge of my graph has to be the high point, and there's an absolute min of y equal to 0 when x equal to 0. And that means the absolute left edge of my graph is going to have the bottom. So when I go to do this on my calculator, I'm going to expect the graph of x e to the x over the window 0 to 3 to have the absolute minimum at the left edge, the absolute maximum at the right edge. Because the y coordinate of the absolute maximum is equal to 60, my window for my y max has to go bigger than 60. So I'm going to graph the function x second and ln for e to the x, set my window to an appropriate window. The x's have to go between 0 and 3, and the negative 10 on the y is not going to mess me up, but if the y max isn't at least 60.26, it's not going to help me. So I'm going to graph it at y max of 70. Now I'm going to hit my graph button, and with this big of a window, I can't see this point 0, 0 so well, but I can see the point 3, 60.26. Let me make sure that the absolute minimum really is at the point 0, 0 by going second calc value, typing in 0, and that confirms that math. And let me make sure the absolute maximum is at the point 3, 60.26 by going second calc value and typing in 3. I better see something that's equivalent to 60.26. And that's spot on. So I feel good about my answer. I've matched it up with my calculator. There isn't anything else I really need to do for that. I didn't take the time to sketch this graph like I had been doing. You really don't have to. You can just inspect the graph. When I go to look at your work in terms of grading, I'm only going to look at the calculus. I'm not going to look at your graph. That's just to help you know that your answer is right. All right, so give 23 a go. I'll move on and do 24. You can do 25. So for 24, I'm going to do it all using my calculus, and then I'll match it up to my calculator. So in problem 24, the first thing I'm going to need to do is take the derivative of the function, and it's just an e function that doesn't have any multiplication preceding it. The derivative of that kind of e function, you just take the e function and you multiply to the left of it the derivative of its exponent. The derivative of 3x squared is 6x. So I have the derivative for problem 24. I'm going to find critical numbers by taking the derivative and setting it equal to 0. And this is going to cause me to go 6x equal to 0 and e to the 3x squared equal to 0. When I do 6x equal to 0, I divide both sides by 6. That's going to give me x equal to 0. And e to the 3x equal to 0 won't have a solution because e to any power can't equal to 0. Now I have to decide if the critical number is a critical number I need to consider. Well, the initial values of x's I was asked to consider were x equal to -1 and x equal to +1. because 0 is between -1 and +1, it's a value of x that I need to consider. So there's 3 values of x I need to consider for maximum and minimum points. I'm going to get the y value for each by plugging them into my original function. So the first y value, I'm going to do f of -1, which is going to be e to the 3 times -1 squared. The exponent of e to the 3 times -1 squared, to simplify it, you do the -1 squared first, and then you get e cubed. So the y coordinate that corresponds to x equal to -1 is e cubed. And if I go to my main screen and do e cubed, so second ln e cubed, the decimal version of this is 20.09. Move on to the next y coordinate, plug 1 into the function. F of 1 is going to be e to the 3 times 1 squared. And I'm going to get the same y value because the exponent reduces to e cubed. And that's still equal to 20.09. Lastly, I'm going to plug 0 in and do f of 0. That's going to be e to the 3 times 0 squared. That's going to be e to the 3 times 0 because 0 squared is 0. And 3 times 0 is 0. That gives me e to the 0. And e to the 0 power, just like anything to the 0 power, is equal to 1. Let me do that real quickly on my calculator. Do e to the 0, I guess. Second ln e to the 0, and it gives me the 1 that I wanted to get. So I think I know my answer. It looks like there's a double absolute maximum and a single absolute minimum. So my guess for an answer for problem 24 is I think there's going to be an absolute maximum of y equal to e cubed, which occurs when x equals to both -1 and 1, and there's an absolute min of y equal to 1 when x equal to 0. Let me make sure this is right by graphing the function f of x equals e to the 3x squared. My x min will be -1, my x max will be 1. My y max has to be at least 20, so maybe I'll make my y max 30. My y min, it doesn't matter, -10 should be fine for it because I don't see any really low y's. So now I'm going to graph the function y equals clear second ln 3x squared, set my window, x min -1, x max 1, y min -10 is fine. I'm going to make my y max 30. It doesn't need to really go up to 70. Hit my graph, and I can kind of see the tie there. Looks like there's an absolute max there, and it's harder to see that that's the 0.01 with this window, but let me do all the y values on my calculator just to show you that these y values are okay by going second calc, hitting enter on value. When I type -1, I should get 20.09, or something that rounds to 20.09. I don't have to hit second calc value again. Now I can just type the number 1 and hit enter and get 20.09, and type 0 and hit enter and get 1. So all my y values are correct, and it's kind of obvious to me that the left and the right edge endpoints are the maximum points, and this point in the middle, which is the 0.01, is the absolute minimum point. All right, so one more problem to go. You have 2 because you get 25 to do right now. Let's work our way and do 26 and 27. Heck, let me do 27 for you just to save you a homework problem. So I'm going to do 27 as opposed to 26. So I'll probably never do 26. So for 27, if I do it by hand, I need to do the derivative. And to do the derivative, I need to use the product rule because there's multiplication and both factors have an x. So I'm going to take the derivative of x squared times the e to the x function unchanged plus the derivative of the e to the x function times the x squared function unchanged. The derivative of x squared is 2x. I'm going to multiply that by the e to the x function unchanged. The derivative of the e to the x function is just e to the x. I multiply that by x squared unchanged. And now I'm going to pull out my common factor. There's definitely a common factor of x between this x and this x squared, and there's a common factor of e to the x as well. So I'm going to factor out both an x and an e to the x. To the left of this plus sign, I'm only left with a 2 when I do that. To the right of the plus sign, I factored out the e to the x. There was an x squared. I took one x away, so I'm still left with another x. So that's completely factored for problem 27 in terms of the derivative. Now I'm going to get the critical values by setting the derivative equal to 0. Since the derivative is factored, I can just take each of the factors and set them equal to 0 to get my critical values. The first one gives me a critical value of x equal to 0 without extra work. The middle one, e to any power, can't ever be 0, so there's no critical values there. And the last one, you minus 2 from both sides and get a critical value of x equal to negative 2. Now I'm going to start doing a table, and I know that negative 3 and positive 1 need to go in my table. They're the given x values. And then when I get the critical numbers, I ask myself, are they in the given interval or outside the given interval? If they're in the given interval, they need to be considered. 0 is in between negative 3 and 1. It needs to be included. Negative 2 is also, it's in between negative 3 and 1. It needs to be included. So those are my x values. For each x, I'm going to get a y by using the original function. So for negative 3, I'm going to go f of negative 3 equals negative 3 squared times e to the negative 3. Negative 3 squared is positive 9. The e to the negative 3 will be made into a positive exponent by moving it to the denominator. So the y coordinate for x equal to negative 3 is 9 over e cubed. I'm going to get a decimal equivalent for that by going to my main screen and go 9 divided by second ln e cubed. And my decimal is, I'll say 0.45. For 1, I'm going to go f of 1, which is going to be 1 squared times e to the 1. 1 squared is 1, e to the 1 is just e. That's just going to give me e. E is like 2.72. If I want to get e by itself, I just hit second and divide. Gives me the e without an exponent, and that rounds to 2.72. For 0, I'm going to go f of 0, which is going to be 0 squared times e to the 0. 0 squared is 0, e to the 0 is 1, and 0 times 1 is 0. And lastly, for negative 2, I'm going to go f of negative 2 is negative 2 squared times e to the negative 2. Negative 2 squared is positive 4, and I'm going to get the e to have a positive exponent by moving this e to the negative 2 down to the denominator. So the y that corresponds to x equal to negative 2 is 4 over e squared, and as a decimal, 4 divided by second ln e squared is 0.54. Now I look at the y, so there's no duplication of the y, so there's only can be one absolute max and one absolute min. The biggest y value is 2.72, so there's going to be my absolute max. And the smallest y value is 0. That's going to be my absolute min. So for an answer for problem 27, I'd probably say there's an absolute max of y equal to e, which occurs when x equal to 1. And there's an absolute min of y equal to 0, which occurs when x equal to 0. Let me match that up on my calculator. When I go to graph this on my calculator, the x min has to be negative 3, the x max has to be 1. If I look at the y values here, they're incredibly small. My y max probably should maybe max out like 3 or 4 or 5. My y min could go down to negative 10. That might even be a little bit too low, but my y max can't go much higher than 3, otherwise I'm not going to see what I need to see. So on my calculator, clear out my screens here, do x squared second second ln e to the x, set my window, x min -3, x max 1, y min, let me just make it really small. I think -10 might be too far down, and y max, I'm going to make it just so it covers up that 2.72. I think that window is going to be really nice in terms of seeing the maximums and the minimums. So it looks to me like right there, that point 0, 0 was the minimum point, and this point 1 comma e was the maximum point. Let me check all my y values to make sure I have the right decimals by going second calc value. I'll type -3 and I hope to get 0.45 or something that rounds to that, which I do. I type in 1 and I get something that rounds to 2.72. I type in 0 and I get 0. I type in -2 and get something that rounds to 0.54. So my math is spot on, and my answer is going to be correct then, because 2.72 is the biggest y value. This point breaks up into the absolute maximum, and 0 is the smallest y value. This point splits up into the absolute minimum. All right, so that's the end of the section. And then we'll just keep mowing through. There's a couple short videos. I think section 4.3 is really short, and of course there's always going to be some long ones. So give this section a go, and we'll just keep plodding along.